lab on camshaft and crankshaft position sensors, and we brought in this 2003 Jeep Wrangler with the 4.0 because the camshaft position sensor is, if you can get right there, it is in a very convenient spot and very easy for testing, and so is the crankshaft position sensor.
Alright, so right now I have the camshaft position sensor connector disconnected, and I'm just going to go through with the voltages. So you have this orange wire here, this pin, that's 5 volts. That one is the supply voltage wire. The middle one here, that one is sitting at around 0 volts, so that one would be the ground. And this one, we already know this from the diagrams. This one's the signal, but it is showing voltage because it is an open. So I'm going to go ahead and plug it in, and then we're going to go ahead and cut back when the engine is running, and I'm going to show you guys the... Now we have the connector back probes on the signal wire, and we have the voltmeter on the hertz setting, so it reads frequency. So you can kind of see it bouncing around. The different readings could be the different notches in the camshaft that tells the PCM where the camshaft currently is in its rotation. And Chuck is going to go ahead and rev the engine a little bit. We're going to see it shake. As you can see, as the RPMs go up, the frequency goes up as well.
Pico-scope right there. We have it hooked up to our signal wire on the camshaft position sensor. The red lead right there. Okay. We go over here back to the pico. We can actually see the screen. We can see the frequency. So we get it's like an on and off wave. It's a digital signal, but if we can stop it, and then we can go back a frame right there, you can see that we now have it all filtered and it's very clean. It's a very on and off wave. But if we go back into play and then we start moving the throttle, we can see that it gets really tight together and starts to read more faster because the camshaft is spinning faster. So just a quick voiceover to explain why we didn't continue testing the crank position sensor on the Wrangler. My key snapped off in the ignition, and I didn't exactly feel comfortable driving it to class, just in case I wasn't able to get it started again. But there are some interesting things that I was able to find on AllData about the crank position sensor, and I will talk about those in a second. So on AllData, there are multiple crankshaft position sensor locations that they're narrowed down by the transmission that is in the vehicle, because there are different types of sensors for each type of transmission. So mine is the 42 RLE, the one that's shown right now, and there's a little slot on the side of the bell housing where the sensor will slide into, and it'll read up against the flex plate. So the flex plate has a little ring that goes around the torque converter with these gaps that are built into it. So by using that, it'll actually be able to determine the engine speed, because the sensor will read that there's a gap, and then it'll ping the PCM and be like, hey, it's going this fast, because we can see the spacing in between the two holes.
Alright everyone, today we got this beautiful unit of a 2017 to 2018 Hyundai Tucson. And currently we are checking the camshaft and crankshaft position sensors. So there's 2 on this motor actually, one for the exhaust and one for the intake. You have the intake camshaft position sensor and the exhaust right here. We are currently pinned into the middle wire, or pin 2 of each connector, and that is the signal wire. And then going down here, you have the connector for the crankshaft position sensor. That's a 2-wire, and it's pin number 2, which when you're looking at the connector, it's the one on the left. So that's the one we're pinned into, and we have it set up on the pico-scope here, and you can actually see the offset that is on each camshaft because the timing on it's different. So you have it 50% on, 50% off for both the intake and the exhaust. You can also kind of see it line up with the crankshaft rotations. So this is one rotation here, and this is another rotation. So if you kind of line it up with, I'll line it up with the intake here. It'll go down for me. Computer's running a little slow. You can see that this off time. Oh, it's still going. Well, it's gone. But you can see before it goes away, you can see that it kind of lines up pretty decently. It could be off a little bit due to regular camshaft timing and everything like that.
At the pico-scope, and we're going to have my partner Kyle, we're going to have him rev the engine, and we're going to see how the channel narrows as it's going faster. So it took a little second for the computer to catch up, but as you can see, if we go back a frame, the scope to catch up, you can see that when the engine was revved, the crankshaft got, like, the channel narrowed, meaning it's going a lot faster, and so did the camshaft. But camshaft is going slower because it only turns once for every 2 crankshaft rotations. So using Google Drawings, I mocked this up really quick. The bottom picture is the spec provided by Hyundai found on ALLDATA, and the top picture is the one that we got from testing on the pico-scope. They are both of the camshaft positions, so exhaust and intake, and the red line is through in the middle of one of the position sensors, and you can see that they are offset pretty equally. It's a little crude, but you can see that they are timed properly, and you could use the data found in ALLDATA to figure out maybe if you skipped a tooth by testing on the pico-scope and seeing if your offset is different than what it should be.